And so when we're talking about filters, there are two large classifications of filters, and a lot of them are determined based on what frequencies they allow or what frequencies they destroy. And so generally we can talk about having a range of frequencies, and there's going to exist a special frequency called a corner frequency, which we'll call WC. And so this corner frequency right here dictates when our filter begins to operate. And for a filter, if it lets in signals below the corner frequency, so let's say that allows signals that are less than the frequency, but then rejects filters that are greater than the corner frequency, we would call this a low-pass filter, because it is allowing signals that are less than the corner frequency. And in the same way of having a low-pass filter, we can also have something that would be called a high-pass filter. So again, I'm looking at a particular filter, and I've got a corner frequency here. If it allows signals that are greater than the corner frequency, so it allows these, but rejects these frequencies, this would be called a high-pass filter. And we can combine these to make more complicated circuits in terms of band pass and band reject, but these are our general two filters that we may have. And so for a given filter, we may design it and we may select this corner frequency, but we also get to pick how discriminating these two filters are between the two different types. So as we'll see in a moment, our filter is not perfect. It's not that if this is set to 100, signals that are at 99 will be automatically rejected and signals that are at 101 will be automatically allowed. We will see that there's actually some roll-off and some trade-off in between these areas, that it's not perfect, but generally we'll talk about the corner frequency where our filter begins to operate.